Okay.
Greetings all. My guest today is Professor Geraint Lewis, an astrophysicist from University of Sydney's Institute of Astronomy. Welcome to AIOCS Conversations.
Hi there.
Good to see you once again, albeit remotely. Now, Geraint and I wrote together a paper, which is forthcoming, on what we know and what we don't know about the universe in scientific and theological perspective. So it has been a very interesting cooperation. And I'm really excited to see how our thoughts are received by the broader audiences. But anyway, as my custom goes, I begin by pointing the viewers to a few web places where we can meet Geraint and his work. And let's try to share my screen to see those few places. First of all, his University of Sydney profile. There you go. There's a lot of stuff there, including an older publication. As these websites go, they usually aren't up to date with people's productions. Then I move to the more exciting page on Amazon.com, where you can find 4 volumes. The most recent one, Where Did the Universe Come From? And Other Cosmic Questions. Published last year, isn't it? Yeah.
Yes.
Yeah. The Cosmic Revolutionary was published after the Fortunate Universe, isn't it? Okay, maybe
that's right. Yeah.
They put them in some order there, whatever. With Luke Barnes and A Fortunate Universe: Life in a Finely Tuned Cosmos, which is actually the book that I would like us to focus today, or at least the topic that is discussed mainly in that book. And of course, a more specialized volume he edited together with someone else, a German name, Darkner, in astroparticle and particle physics. But for those like me, who have no idea of science apart from popular crumbles that we get, there's plenty to feast on when you go to YouTube and you see here the channel Alas, Lewis and Barnes, where Geraint has funny but also serious conversations with Luke Barnes on matters on heaven and on earth. It's a delight. I'm a fan of this channel since last year when I discovered it for the first time.
Fantastic.
Now, Geraint was kind to agree to speak to me and to you, the audience, about fine-tuning. It appears that we witness a radical, let's call it paradigm shift, isn't it, from the views of researchers and thinkers of, say, 50 years or more ago, in fact, from the beginning of modernity, who were keen to decentralize humankind and its place in the universe. We all heard so many stories, so many times of how insignificant we are living on a tiny rocky planet, a speck of dust, orbiting a small star, lost in the wastelands of the galactic outskirts, of a cradle of stars swimming in the vastness of the local galactic group itself, a mere nothing compared to the inscrutable horizons of the universe. I get a bit pathetic and rhetorical when I get to this topic, because that was the narrative, isn't it? That we are nothing and therefore we shouldn't claim anything apart from the capacity to realize that we are nothing. But I won't mention the multiverse or other hypothetical universes, since you, Geraint, prefer to stick to facts when it comes to science. I agree.
Yeah.
Anyway, reading your book written with Luke Barnes in 2016, A Fortunate Universe, I was struck by the realization of this paradigm shift, as I call it. Your message is that marginal as we are, we still live in a beautiful, finely tuned world, finely tuned for life, where things seem to have conspired in favor of our existence. Related, and to paraphrase you once again, you also point out that we are not as mediocre as it seems, which is good news. This is so far from the previous narrative of gloom and doom, of desolation and insignificance, I believe. Let's get to business. So what is fine-tuning, and what are the main proofs in favor of a finely tuned cosmos?
Okay, so fine-tuning is a very loaded phrase in physics. It can actually get people quite excited and sometimes quite angry when you talk about fine-tuning. So we need to be very careful and talk about what we mean when we talk about scientific fine-tuning. So when we have the laws of physics, right? So since the time of Galileo through Newton, etc., we've realized that if we were going to describe the universe as a physicist would describe the universe, we need a language, and that language is mathematics. So if I have a problem that I'm trying to deal with, I want to write down an equation. So I want to work out how the moon goes around the Earth. I go back to Newton and look at Newton's equations. I want to just talk about how an electron behaves in an atom. There's a different set of equations, quantum mechanics. Now, you might think that the job of a physicist is to work out these equations and then off you go, right? That at some level, you could take me and lock me in a box at some level with these equations and I could predict the universe. Except that there's a problem. And the problem is that in all physics equations, there are certain numbers, we call them the constants of nature, right? So if I want to calculate the orbit of the moon around the Earth, I know that Newton gave me this expression about it's related to the mass of the moon and the mass of the Earth and the distance between them. But I want to know the force because it's the force that dictates the motion of the moon. And to turn those numbers of masses and distances into a force, I need another piece of information. This is Newton's gravitational constant, right? Now, you might say, right, but you derived your equations. Isn't it just a number? Is it like, pi squared or something like that? And the answer is that no, these numbers, we don't find mathematical relationships for them. What we find is that we have to go out and ask nature, what is the value of Newton's gravitational constant? I have to do experiments to measure what that number is before I can use my equations. So my equations are sterile until I have this number. And it's not just in gravity, but there's a whole swathe of these numbers across physics. The speed of light, right? There is the strength of the electromagnetic force or the weak force. There's numbers like Planck's constant that tell you about how the quantum world works. None of these numbers are things you can derive in terms of a mathematical expression. You have to measure them. And as soon as you have these numbers, right, you're struck by the question is, well, why are they the numbers that they are? Now, of course, there are some slightly complicated issues here that most of these numbers have units, right? So, I can change the speed of light from meters per second into furlongs per year, right? I've just changed the units. But I can construct numbers that don't have these units, right? I can have combinations such that I don't have to worry about kilograms and pounds and etc. And I have these numbers. And I want to know, why do these numbers take on the values that they do? And what if they weren't the values that we see them at? So this is where physics starts to play, right? So physics is it's one of those things that historians hate, right? The counterfactual history. You play counterfactual physics, right? What if I had a universe where my constants weren't the values we've got here, but are some different values, right? So I can write down equations. I can put in a different speed of light, different strength of gravity, and I can ask myself, what is that universe going to be like? And this is when we run into this notion of fine tuning, because what we find is that if we take things like, say the relative strength of gravity and electromagnetism, the two big forces in the universe that we worry about. Now, the sun operates by a balance, essentially, between these plus nuclear forces. And if I mess around with the balance of those forces, I make stars that don't burn for billions of years. They're unstable, right? They just don't last very long. And that turns out to be bad for life, right? One of the things that we think has been very, very important for life on the Earth is the fact that the sun has burnt stably for around 5 billion years. And we can ask ourselves, well, what would happen in a universe where stars only lasted 1 million years or 1,000 years or a year? You know, you can mess around with these numbers. And what we find is that when we explore all of these constants of nature, that it seems that our universe is in a small region in this big possible configuration space of universes, where we can have conditions that we think you need for life. And everywhere else, these universes are effectively dead and sterile, right? Either they're empty or they're cold, they're too simple, they don't last long enough. And we're in this little region, a bubble, where importantly, we can have complexity, right? It's complexity in our universe. The fact that we have a periodic table, that periodic table can combine to give you molecules, those molecules combine to give me and you, right? It's ultimately that complexity is the thing that we need for life. So in the entire, the fine-tuning picture, that was a long-winded story there, is that somehow our universe is in this region where you can have complexity. And if it was somewhere else, right, we wouldn't have complexity and we wouldn't be here to ask the question.
Yeah, if I may interrupt you, I think I have an understanding of what you say, because some years ago, 2018, I had a stint in Durham and I met your colleague, Richard Bauer. And,
oh, yes.
Yeah, and he was toying with a machine, the universe maker, and he showed me how to push some buttons and change the constants of nature. One of them was the quantity of dark matter and what its impact is on the accretion of matter in the universe. And yeah, I realized how sort of narrow the margin is for life to exist.
Absolutely, absolutely. And it's everywhere you look, right? So, you know, we are, right? We are the laws of physics writ large in some sense, right? So, and it's not just the laws of physics as it is today, but also the entire evolution of the universe, right? For me to be here today, right, I needed the universe to be born with a certain mix of elements, with not a perfect distribution of matter. It had to be slightly imperfect to allow galaxies to form, then for generations of stars. And those generation of stars make the carbon and the oxygen that's inside me. Dying stars make the gold in this ring. All of that, I'm a culmination of the laws of physics over 14 billion years. And it's easy to mess around with this small scale stuff, that the imprint when we get to today is a radically different universe. And that's what we want to know is why. Why is it that we ended up in this seemingly small region of complexity in this potential configuration space?
And I understand that there's a range of such constants of nature that somehow conspire towards our existence. Therefore, the fine-tuning concept actually refers to a great many categories of numbers. Yeah, so we don't get into this kind of detail. I noticed recently, so because I haven't been very much into this topic up until months actually ago, that there are critics of fine-tuning. There are scientists who, for one reason or another, choose not to use this concept, and somehow they just go by the same old, well, it's all random, it just happened, and so on and so forth. I don't know if it's the case for us to get into the details, the nitty-gritty aspects of those criticisms, but what would you reckon pushes these people to resist the idea of fine-tuning in the universe?
Well, I think it's similar to that issue I mentioned about historians, right? Real historians don't do counterfactual history. The job of a historian is to unpack what has happened along a timeline, not to think about how that timeline could have been different. But we know that there are historians that also do the counterfactual. Now, when I talk to a lot of physicists, they also have this notion that the role of physics is to understand this universe, and that's it. And therefore, you're somehow stepping outside the bounds of physics by asking these questions of what else is going on, possibly beyond. Now, in the same way as there are counterfactual historians, there are counterfactual physicists. So there's no single viewpoint, right? I mean, I have an argument with a philosopher friend of mine who treats physicists as if we act as a block, that we are the Borg, we're a single mindset, and this is what we do. And what the realization is, of course, is that there is a spread across physics between those that think that this is not even an interesting question because their physics work doesn't really care about the fundamental. But I've normally found that if you give a talk on this topic to a room full of physicists, it will spark a lot of heated discussion and debate. And a lot of it then goes back not to the physics, but the philosophy of physics, right? Why are we doing this topic in the first place? And to some people, as I said, it's to understand this universe. To others, it's to understand the bigger question, which into the realm of metaphysics of why this universe. So yeah, it's a bit of a messy field.
Yeah. And my look, listening actually on YouTube on some interviews with the critics of fine-tuning, I had this distinct feeling that what they tried to avoid was not even that idea of writing alternative histories of the universe or something like that, but I think they just feared the invasion of philosophy and metaphysics and theology, and I think that's a legitimate concern. But listening to you, I realized that there's this other approach to things where we shouldn't actually fear thinking around the available data, trying to make sense, even for people like me who don't have a scientific background. And I believe that it's obvious for everyone listening to this recording that if you started now to blurt some equations, you would have lost me and most of the viewers. So the fact that you think and find it a valid way of talking about these things in a language that somehow borders with philosophy, I think that's very useful, but also hope-giving, because I think we all want to make sense of the universe. I don't think there's a real person, a human being, that doesn't want to understand things. Just saying, well, look, we don't think in terms of fine-tuning because it's too metaphysical an approach, that blocks most of us who don't have the real tools. How will we understand? So what you do is tremendously important for people like me and others that have questions.
I mean, yeah, it is. So personally, I'm very happy to ask those questions. I can tell you why some scientists want to shut this kind of topic down. And it's not only the prospect of bringing metaphysics into and philosophy into physical discussions. The problem that they see is that when you, as we wrote in the book, right, there are solutions to fine-tuning. And I'm going to put solutions in air quotes because in reality what they are is that they're hypotheses, okay? We can solve fine-tuning if it's this or that, right? Now, to my mind, that's a hypothesis. That's a starting point of a scientific exploration. And from there, you build up more experiments, etc., to try and test these things. Whereas other people think that if I talk about fine-tuning and I put like a concept like the multiverse on the table, then at some level that I'm done, right? I've answered the question, it's the multiverse, I've walked away, but I haven't really answered anything because we don't even know if the multiverse is a testable kind of hypothesis yet. So I think there's a friction there because of a diversity of views of even what science is, right? And some people in their mind, science is only science once it's testable. Others, science is a bigger endeavor, proposing hypotheses and then test the hypotheses, etc. And so, yeah, it's because there's no single viewpoint on how you should approach these kind of questions that leads to the friction.
Yeah. So this is more a matter of, if I hear you correctly, more a matter of having different views about science itself rather than adopting a polemical stance just in case there will be tomorrow or the day after some theological metaphysical invasion of the land of science. But I can just say thank God for people who have a broader understanding. I mean, scientists who have a broader understanding of things and make room for at least for discussion. Look, I read with so much enthusiasm that funny, serious conversation, that dialogue that you and Luke had in the beginning and at the end of the book. That was such an amazing discussion. You emulated Galileo's dialogue of the systems of the world, and you discussed, all sorts of matters from the multiverse to the G word. Philosophy and theological arguments in favor of God's existence and otherwise. And I think that this is the right way. I mean, no one expects a scientist to find proofs for God by way of experiment. I don't expect that, for instance. Mm-hmm. I think it's so fertile, so uplifting to see this kind of discussion, allowing for a variety of perspectives, regardless of how in agreement or not you might be as a scientist. I think that's something that is intrinsically human, and I think it gives us hope that we can progress together regardless of where we come from and what kind of perspective in life we adopt. Would you like to comment on that conversation that you had with Luke Barnes about the G word?
Yeah. So just to understand, firstly, why we wrote the book, right? So Luke used to be my undergraduate student at Sydney University, and he comes from a theistic background. I'm an atheistic background, and what we spoke on the topic of fine-tuning, and the thing that frustrated us the most is that there are two sides, atheistic, theistic, right? And all they do is shout at each other, right? That's all they do, right? So the discussion, right? And for us, the thing that annoyed us most is the discussion of the science. It just becomes a minefield, because if you're on one side, if you're on the atheistic side, then if you don't like the fine-tuning argument, then you just don't bother talking about the science. You say that the science is wrong, etc. If you're on the theistic side and you say, oh, look, this is what the science is telling us, therefore this proves that, you know, there's a God that designed the universe. And we just felt that the two camps, right, that they weren't going to get anywhere by just yelling. So what we wanted to do in the book is we wanted to lay out the scientific arguments, and that's what the majority of the book talks about, is ways that you can destroy the universe by messing around with fundamental physics, right? There is no doubt that if we did have different values of the fundamental constants, we would have a radically different universe. So there's no argument there, right? So the arguments start when we get to the latter part of the book, and that is, why are we in this situation? And again, you can have, the important thing to say is that when we get to the latter part, neither of these sides can claim the high ground, right? There's the science, and then you can say, this is my interpretation of what's going on. And it can either be in terms of physics, or it could be in terms of a creator, or whatever, etc. But nobody can say, slam their fist down and say, right, my side is right because we have the science, and that is it. That is it. Nobody has the next step of level of solution to these problems. So that's what we wanted to do. But of course, when Luke and I were speaking about this, and the conversation actually reflects the fact that we do talk to each other. We do cover this kind of ground, and Luke gives me his viewpoint, the theistic side of things, and I talk about. We both talk about the potential physics solution in there as well, and I actually think that. I hope that we got across in our discussion that neither of us basically thinks that we won any kind of argument, right? That we had the discussion.
If I can interrupt you for a bit, the book actually ends with this line, narrator. So the narrator of the dialogue. Our two cosmologists head off in different directions, slowly being swallowed up by the darkness. I mean, it's you can take it at face value, okay, to people parting ways after having a beer and a conversation, but then you can take it figuratively, as different perspectives, different ways of looking at things, and getting lost in the dark. It's amazing.
Yeah. Well, I mean, I'm not sure if we set out to be so poetic when we wrote it, but some of the lines I thought did sort of at least convey where we think things are, right? We both think that there really is an issue with regards to our universe, right? We just definitely think that there is something peculiar going on, right? Now, as you said, that we may never, ever understand that peculiarity, right? We may never work it out. But if we do, and again, from either the physics viewpoint or even the theological viewpoint, then that's going to be pretty cool for somebody, right? But at the moment, we just don't know. But there are signs that there is something strange about our universe, and it does bother me somewhat, right? That as I said, how easy it is to come up with a hypothetical but sterile universe. It's just such an easy thing to do. And as you said, playing with the universe making machine in Durham shows you that.
Yeah. That was such an illuminating experience, really. I mean, it's a toy. You push some buttons there and change the constants of nature, and you realize that it takes so much effort and calculation actually to get the right equation, to get the right amount of this and that and this and that, to get to life in the universe. Yeah, the universe is strange. I love this. I don't need a statement from you, okay, so this makes room for God, but that's my job, to say that might make room for God. But the fact that you say it's strange, and as per our discussion in that chapter with what we know, what we don't know, again you prove once again this wonderful capacity to make room for well, dots, 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 because we haven't reached any result yet. I mean, yeah.
So I'm a cosmologist, right? So I study the evolution of the universe, and I teach relativity as part of my my teaching. And in there are two big mysteries, right? Number one is, where did the universe come from? How was the universe born? And number two is, what happens at the heart of a black hole? You know, something's completely collapsed. And these are mysteries that people have struggled over for a long, long time. And there's this search for this theory of everything, okay? And there's a hope that this theory of everything will shine a light somewhat on this fine-tuning issue with regards to our universe. So this is the kind of thing that, you know, I started off wondering about those mysteries and then came to the entire fine-tuning thing. But, you know, it's still somewhat haunting that they might not answer that question, right? And, you know, we do mention this, I think, in the book. I think we called it the Lady Gaga.
Oh yeah. Yes.
That the universe was just born this way, and we will never ever understand why it's the way it is. And, you know, that's a haunting thing, that we'll never be able to work that out. And we just have to live with the fact that this is the universe that we've got. So,
you know, there are some religious traditions that actually agree with you wholeheartedly. For instance, I read some years ago, I don't even remember the name of the book or the author. I think it was a Jewish rabbi. It was about Genesis. That's my lasting hobby and interest. And he said, have you ever looked at the Hebrew text of Genesis? It begins with what you, from the Western world, whatever, you'll see like a square bracket that opens towards the text. And he says, there's no way of even guessing what's before that opening square bracket. Yeah. And I think that this is a very important observation. It's empirical, having to do with the text that means something or means a lot to more than the Hebrew tradition, you know, including for Christians and Muslims and so on and so forth. And ultimately, we can't say anything. In my own Christian tradition, so I'm Eastern Orthodox, there's a kind of doing theology called apophaticism. I don't want to infect you with this kind of stuff, but anyway, which basically says, look, we go with our reason and reasoning and argumentation and so on and so forth so far. There's a line that we have to draw when we should simply shut up and revere the mystery in silence. The word apophaticism is from Greek, and it means simply to shut up, abstain from saying anything, because there is a limit to everything that we can know. But this doesn't mean, you know, we leave room for all those things, God's mysterious ways and stuff. No, it's really humbly accepting the fact that there are things that we don't know.
Yep.
And I think it's so important to be able to recognize this and then to make room, as you do, I think, for a variety of perspectives. You don't have to agree with any of those other perspectives, but it's interesting to listen to them. And if I may, perhaps moving towards conclusion, because I know you are in a hurry, you have another meeting. I could give you this. It's like a joke. I don't know. I haven't found it written anywhere. I heard it from a number of sources. It's a saying attributed to a famous Orthodox theologian of our time, Metropolitan Kallistos Ware, English, and an Englishman, and he is supposedly the author of this saying. So there's this table, and at the table, you know, in a pub, yeah, famous analogy in your book. In a pub, there's this table, and at the table there are three people sitting, sipping whatever they drink. And One of them is Greek, the other one is Roman, the other one is Jewish. So late antiquity, coming sort of back to, to my area of interest. And they all wonder about that table, you know. And the Greek guy says, well, what is this made of? Okay, knocking, and is it wood? Is it iron? Is it marble? What is it made of? The Roman guy says, well, what is it good for? How can I use it? You know, these are idiosyncrasies of those cultures. The Greeks, indeed, with their metaphysics, were obsessed with knowing what's the ultimate reality. You know, what is it made of? Romans made laws and whatever, roads, you know, road makers, and they have this pragmatic mentality. What is it good for? How can I use it? And the Jew says, well, who made it? Because in the book of Genesis, the book of Genesis begins with who made it, not what was made, or well, that too, but who made it? And so these are three different viewpoints, and Metropolitan Callistos would apply this kind of this analogy to a number of things, and I usually apply it to this kind of conversation in regard to what is reality, or what's the universe, or how can we perceive the universe. And for instance, for me as a good Jew, what matters is who made it, and that's my question that haunts me. And you are a good Greek, and you ask yourself, what is it made of? What are the building blocks? Stuff like that. And perhaps other people are more pragmatic and say, well, how can I put it to a good use, you know? But the idea is these three perspectives, and perhaps many more others, don't have to agree. What's interesting is that all of them refer to the same table, in this case, the same universe. And why I say this is because even recently I was a member of a panel discussion, and a fellow Orthodox person with a scientific background said, well, look, theology and science have different objects. They focus on different things. And I said, well, look, this doesn't sit right with me, because my job is to see how the early Christians, for instance, were looking at the universe, how they lived in the world, how they conceived the cosmos. What was the cosmos for them? You know, of course, that's not a scientific perception of reality the way we understand science today. But this doesn't mean that Christians or other religious people are obsessed with God, and they have no say in matters pertaining to the universe. How do you feel about this analogy and its ramifications?
Yeah, I mean, I agree with the analogy, Anna, but I actually think that there are a subset of scientists that, you know, the who made it can be turned into a physics question, right? This is where the multiverse comes into play, right? That's the who made it, right? Because you go beyond just this universe and talk about universes within the multiverse, etc. Of course, you can always push this back and who made the multiverse, but you know, one step.
Well, actually, we discussed that with Luke Barnes in the book, yeah.
Yeah. Yeah, and I mean, I guess one of the things that's often not appreciated, I get told this a lot, that there is science and there is religion, and they're two very different things. And there are a lot of people in science who have a religious/spiritual side to them. So even though, you know, you might say, oh, physics, that just deals with the cold, hard facts. But you have people like Luke, and he's not alone as a scientist. There's somebody who studies the entire cosmos that has that side to them. They cannot be that different, that in Luke's mind that there are two compartments, that there's science and there's his spiritual side, and they don't interact, right? It's impossible. And there are a lot more people, I think, and it's appreciated, that have that side to them. Of course, there's a also a reasonable number like myself that don't go down that particular road. But it's not like that. It's not like you have to be an atheist to be a scientist. I just think that's, and I have found that viewpoint with some people, that they think that because you're a scientist, therefore you can't have any other sort of aspect to the universe inside your mind. And I think it's just wrong, and it leads to this friction, right? I was recently involved in a discussion about how science and religion should interact, and I think that they do interact quite a lot. But the problem is that you've got everyone interacting, and then here you've got your one side shouting, here you've got the other side shouting, and these are the only voices that are heard, right? Krauss and Dawkins on one side, and there's the range of especially the creationist side of things shouted on this side, as if they are the only voices, and they're not, right? I hate the phrase silent majority, but I think there's this big silent majority where they have both aspects.
That's amazing. Thank you very much, Geraint, for this insightful conversation. It has been such a pleasure. I'm certain that our audience will also enjoy it immensely. I'm really honored, and there's such a great pleasure to have you talking to me and to the viewers. Thanks a lot.
Thank you. It was always great to talk about science and the universe.
Awesome.